Hello students. So as I have already told you that I will be discussing some important question answers in my channel and I will be posting it. Yes. So now I am beginning the discussion of some important question answers with some 5 MCQs. Okay. For the first chapter, that is matter in our surroundings. Okay. And today we will be looking at 5 important questions, and that is I think also important for improving your concepts in this chapter. Okay, so this is very important. So I will be discussing with you now, and please listen carefully. And this is all the questions are from this chapter only, and if you use your concept and if you give your full concentration, then you can easily find the answers of it. Okay, so not very difficult. The only thing you need is you have to have a clear concept on the chapter. Okay, so let's start. So the first MCQ, that is, the question is the distance between the molecules of CO2, and CO2 is carbon dioxide, will increase, and there are 4 conditions given. So when the distance between the molecules of CO2 can increase, so there are 4 conditions. Number 1, on increasing the pressure on the carbon dioxide present inside a cylinder, that is carbon dioxide is present in a cylinder and we are increasing pressure. Number 2, on increasing the volume of the cylinder, that is if the cylinder size is increased. Number 3, if CO2 leaks out of the cylinder, that is some of the carbon dioxide gas, if it leaks out of the cylinder. And number 4, if we add more carbon dioxide to the same cylinder, that is to the same cylinder which already has carbon dioxide, again if we are putting carbon dioxide gas in the same cylinder. So this is the 4 condition, that is we are given 4 condition and we have to see in which of this condition the distance between the carbon dioxide molecule will increase. Okay, so carbon dioxide molecule is the particle of carbon dioxide gas. Okay, so that means if these are the 2 particles, suppose this is particle, and if its distance should increase, so that means what, these particles have to move to a larger distance. Okay, so for the distance between these 2 particles to increase, one particle should move away from the other. Yes, only then the distance will increase. So for these to occur, what should happen, that the gas should occupy a larger amount of volume, or the gas should be more freely able to, the gas should be able to move more freely in a greater space. Okay, so that means number 1 condition is that the volume of the gas should increase. Okay, so now look at the conditions given here. So first is on increasing the pressure. So what we know, when we increase the pressure, the gas will be compressed, and when a gas is compressed, what we see, its volume is reduced. Yes, because suppose this is a container and we are applying pressure. So what happens, when we apply more pressure, gas will come up to this much. Yes, from this position. So that means when we apply pressure, what happens, the volume of the gas gets reduced, and this is what compressibility means. Okay, so number 1 condition is completely incorrect. So now let us look at number 2, on increasing the volume of the cylinder. So that means if we increase the size of the cylinder, then its volume will increase. So when volume will increase, now see, if we are using a small container, okay, and if it is filled up with gas, okay, and the same amount of gas is if we are using it in a large container. Okay, so what will happen, we all know that gases fills completely the volume of the container in which it is kept. So if this container has this much amount of gas, and if the same amount of gas is transferred to this cylinder, then it will occupy this much volume. Yes, so that means what we see, that if the volume of the cylinder is increased, the volume of the gas will also increase. So if the volume of the gas increases, then what we can see, we will see that the gas particles which was present here nearby one another, now this gas particle will be able to move to a larger distance. So that means the distance between them will increase. So from this we can say that second condition will increase the distance between the gas particle due to the increase in the volume. Okay, so that means the second condition is the answer of this question, that is the distance between the molecules of carbon dioxide will increase when we increase the volume of the cylinder. Okay, so again now let's see on the third and fourth option also. So in the third option what we see, if CO2 leaks out of the cylinder. Okay, so now if CO2 leaks out of the cylinder, that means first in cylinder we have limited space. Okay, so the gases are present in this cylinder, that means the gases have only a definite space, that means they can move only inside this cylinder. So if some of the carbon dioxide comes out, okay, so now they do not have any boundary, so they can move to any direction they want and at any distance, and can go to any distance. So that means here their movement is restricted only inside the cylinder, but once the gas leaks out means come out of the cylinder, then it can move freely in whole of the atmosphere, whole of the air. Okay, so there they can move to their maximum distance. So that means the distance between the particle will also increase. So the third option which is given, that is the third condition which is given, is also satisfying the question. That is, if some CO2 gas leaks out of the cylinder, then also we will see that the distance between the molecule of carbon dioxide gas will increase. Okay, so we have seen that second and third satisfied. Now let us look on fourth condition. So if we add more CO2 to the same cylinder, that means we already had, suppose we are considering the cylinder and we already have this cylinder, it already contains this much amount of gas. If we will add more amount of gas, then what will happen? So it already had gas, again we are adding more amount of gas. So that means if we zoom on it, okay, then what we will see, if we zoom, what we will see, that already it had this many particles, this many gaseous particles, okay, inside the cylinder. Again in the same volume we are adding more amount of gas particles. Yes, so we are adding more amount of gas particles. So that means what it means, the distance between the particles now decreases, because in the same amount of volume we are adding more amount of gas. Okay, so this is why we will see that the distance between the particle of the CO2 gas in fourth condition will decrease, it will not increase. Okay, so the fourth condition is wrong. So what we have seen, only second and third condition will increase the distance between the molecules of carbon dioxide. So that is, from there in this question we have 5 options. Yes, so these are the 5 options, and we see that in A it is given 1 and 2, which is not correct because 1 do not satisfy. Number B, 1 and 3, so here also the option 1 is not the correct answer. Now let us see on number C. So in C what we see, that second and third is given. Okay, and we have seen that only second and third satisfy the question number 1. So that is why we can say that option C is the correct answer. So now let us look what will be the exactly correct answer. So according to us, number C is the correct answer. Yes, so yes, the answer is C. Okay, so why C? Because on increasing the volume only we can say that if the volume of the gas will increase, only then the distance between the particles of the gas will increase. Okay, so and if carbon dioxide gas leaks out of the cylinder, then also the gas particles, that is the molecules of the gas, are free to move to a greater amount of space in a greater distance. Okay, so if their movement will be in a greater distance, so their distance between the particles will also increase. Okay, so this is the answer to question number 1. Now question number 2, which one of the following set of phenomena would increase on raising the temperature? Okay, so here are some processes that we have already discussed, like diffusion, evaporation, compression of gas, expansion of gas. Okay, so if we increase the gas, okay, so which of these processes will take place at a faster rate? So this is the question. Okay, so now let us look at option A. So here the options processes are diffusion, evaporation and compression of gas. So what we know, that with increase in temperature diffusion increases. Okay, Again, we know that with increase in temperature, evaporation also increases. But on increasing temperature, compression of gas do not occur, because what we see that while compressing gas, what happens? Gases turns to liquid. Okay, and what are the two conditions to change gases into liquid? Number one is compressing by applying pressure and by reducing temperature. So if we will increase the temperature, we will be requiring more amount of pressure. So that means compression of gas will become difficult. Okay, so number A, it does not satisfy the condition because compression of gas does not occur quickly, or it does not increases with increasing temperature. So A is wrong. So now look at B. So here also the same problem, compression of gas. So compression of gas cannot occur when temperature is increased. Okay, that is compression of gas will be requiring more amount of time if the temperature of the gas is increased. Now number C, evaporation, expansion and diffusion. So expansion is completely the opposite of compression. In compression, what happens? Volume of any substance it reduces, and in expansion volume will increase. Okay, and if we need to reduce, what we saw that by reducing the temperature and by increasing the pressure, a gas can be compressed. Similarly, by reducing the pressure and increasing the temperature, we will see that a gas expands. So when you heat a gas, what happens? The volume of the gas increases, that is gas expands. Okay, so all the three conditions here, that is evaporation also increases when temperature is increased, gas expands when temperature is increased, diffusion of gas also takes place at a more greater speed when temperature is increased. So that means option C satisfies the question, that is all the processes given in option C will increase when temperature is raised. Okay, now again let us look at D, that evaporation, condensation and compression of gas. So here also this condensation, so condensation cannot occur when temperature is increased. Condensation only occurs when a object at a higher temperature, that is a hotter body, when it comes in contact with a cold body. Okay, so only then the temperature will the heat will be conducted from the hotter object to the cooler object. So that means one of the object during the process of condensation should be at a lower temperature, only then condensation will increase. So that is why we see that condensation takes place rapidly when a bottle which is being kept in the freezer, if you bring it out of the freezer and if you keep it in a table, we will see that at the surface of the bottle containing the chilled water, you will see that condensation of water vapor takes place and liquid droplets, water droplets starts to form on the surface of the bottle. So here, according to the discussion that we have already done and according to what we have learned on this chapter, in this chapter, according to that, our answer should be option C. So now let us look at the correct answer. So correct answer is C. Okay. So this is a very easy question. What the question says, that a state of matter. So what are the three states of matter that we have learned? Solid, liquid and gas. So a state of matter has a property of flow, okay, and have a fixed volume. An example of such matter is, so that is there are three states of matter, and other is given that in a states of matter that have the property to flow and also have a fixed volume. Okay, and here are four options, and all the four options contain the name of some matter. Okay, so which of this matter exists in the state which have the full given property, that is property to flow and have a fixed volume. So now let us look at the question one more time. That is, a state of matter has the property to flow. So what are the states of matter that has the property to flow? One is liquid and one is gas. Okay, so that means the answer to this question cannot be a solid. So now let us look at the option. So here table is given. So table is not a liquid or not a gas, it is a solid. So this cannot be the answer of this question. Yes, so number A cannot be the answer. So now let us look at the second property, that is it have a fixed volume. So only two states of matter can flow, that is, one is liquid and one is gas, and we know that only liquid have a fixed volume, gas do not have a fixed volume. So that means the answer for this question, that is an example of such a matter which can flow and will have a fixed volume, should be a liquid. So among the option that is given here, so which one of these option is a liquid, we have to look. So table, it is solid, air, it is gas, dry ice. So dry ice is again solid form of carbon dioxide. So the only option that is correct is bromine at room temperature, because we know that bromine is the only non-metal which is liquid at room temperature. Okay, so bromine always exists in its liquid form when in present in room temperature. Okay, so bromine is liquid, and the answer for this question should be a liquid, and only bromine, that is option D, exists as a liquid. Okay, so option D should be the correct answer. So the answer is option D. Okay, so very easy question it was. Now let us look at question number 4. What happens when water at 0 degree Celsius freezes to ice at the same temperature? So option A is water absorbs heat, option B is water releases heat, option C is neither heat is released nor heat is absorbed, number D is absorbs heat only when temperature rises to 1 degree Celsius. Okay, so to give the answer, first we have to understand what happens during freezing. Okay, so I have already said that gases always have the highest energy, then liquid, then solid. Yes, so if we write the energy, then gases will have the highest energy, then liquid, then solid. Okay, so what is given? Water at 0 degree Celsius will have higher energy than ice at 0 degree Celsius, because here it is given same temperature. Yes, so water at 0 degree Celsius will be having higher energy than ice at 0 degree Celsius. Okay, so here what means? Water is changing into ice. Okay, and temperature is 0 degree Celsius. So temperature is fixed. Okay, so now who have the higher energy? Water. So when this process occurs, so what happens? A higher energy object, that is water, is changing into a lower energy matter, that is ice. So that means the extra energy what is present in water, it should go out of the water, because if the same energy will be present in ice, then ice cannot exist in its solid form, because we know that energy of water is higher than energy of solid, and ice is a solid. Okay, and so ice should have lower energy than water. So the extra amount of energy that the water contains, so it must be released. Okay, it cannot go to ice. So that is why we will see that extra energy is released as heat. Okay, so what happens? That water will release heat. So what is the option that says this? Option B. So option B is the correct answer. Okay, so very simple. Only you have to know that what is the energy of water and what is the energy of ice. That means we should know that energy of liquid is always higher than energy of solid. Okay, and since ice is a solid, it have lower energy than water. So when water changes into ice at the same temperature, the extra amount of energy that the water molecules have, that the particles of water have, they have to lose that energy. Okay, and how they will lose that energy? They will lose it by releasing it as heat. Okay, so the answer is B. Okay, so now this one is an interesting question. What is given? That 4 students, they have taken sand, common salt. So what is common salt? That is salt that we use in kitchen. So they have taken sand, salt, and ammonium chloride in a beaker. Okay, and then they added water to it. Okay, and they mixed it, and they thought of now filtering the whole mixture. Okay, now the mixture has sand, salt, ammonium chloride, and also water. Okay, so now they are thinking of to filter it. Okay, and what we see, whenever we filter anything, So suppose we are filtering anything, so what we will see, this is a funnel. Okay, so when we will filter, some things will be left here. Okay, and we will get liquid here. Okay, so the things which are left here, which cannot pass through this, these are known as residue. Okay, and the things which are obtained as a liquid or which are present in the solution in a liquid, these are known as filtrate. Okay, so what is residue? Residue is the metals or the substances which leaves behind when we do filtration. And what are filtrate? So filtrate is the substance we get it, what we get in the liquid form. Okay, so filtrate will be always present as the liquid and residue will be present as a solid in the filtrating devices. Okay, so now all the 4 students, they have wrote their observation. It is student 1 has written that ammonium chloride is the residue and the filter will be sand and common salt. Student 2 has written as common salt and sand is the residue and ammonium chloride is the filter. That means student 1 is writing that ammonium chloride will leave as a solid and sand and common salt will be mixed in the water and it will be present in the liquid. Number 2 is writing that common salt and sand will be present in the filtrating device as a solid, as a residue, and ammonium chloride will be mixed with the water and it will go as a liquid. Number 3, the third student is writing that sand and ammonium chloride will be left behind as a solid substance and salt will be mixed with the water and it will go as the liquid substance, liquid solution. Number 4, the fourth student is writing that only sand will be left behind as the solid substance and both ammonium chloride and common salt will be mixed with the water and it will go as a liquid. So the question is, which of the 4 student has done the experiment correctly and has written its observation correctly? So what we know, that common salt, it dissolves in water. So anything that dissolves in water, it will move along with the water and it will be present in the filtrate. Okay, so whenever you try to dissolve sand in water, you cannot dissolve sand in water. So that means whenever you will filter a solution containing sand and water, okay, then you will always see that sand will remain as a residue and water will move, water will pass as a filtrate. Okay, so that means one thing is fixed, that the residue must contain sand. Okay, so the residue must contain sand, so option 1 cannot be correct. Okay, and you know that salt always dissolves in water, therefore salt cannot be present as a residue, so option 2 is also wrong. Okay, so only third and fourth option may be correct. Okay, so now ammonium chloride. So ammonium chloride is also a water soluble salt. Okay, so ammonium chloride also dissolves in water. Okay, so like the general salt, that is the sodium chloride which you use in kitchen, like sodium chloride dissolves in water, ammonium chloride also dissolves in water. Okay, and anything that dissolves completely in water, it will be present in the filtrate, so it will move along with the water as a solution. Okay, it will never be present in the residue. So number third option is also wrong, because ammonium chloride is soluble in water, so it cannot be present in the residue. Okay, so the correct answer is only student 4, the fourth student, has done this experiment correctly. So the option which contains 4 is option B. Yes, so the correct answer of this question is option B. Why option B? Because only the fourth student has written the observation correctly, that is sand will be present as the residue, that is sand will leave behind, and ammonium chloride and salt both will dissolve in water and it will move as the filtrate. Okay, so these are the 5 questions in which that I have discussed today, and for answering these 5 questions you have to have a strong knowledge of chapter 1 and your concept must be clear. Okay, so these are only 5 questions, 5 MCQs that I have discussed today. So similarly I will be discussing more question and answers related to every chapter. Okay, so important question and answer For better understanding and improving your concept, I will be discussing such question and answer after every chapter. So I will be posting it in my channel. So due to this, I again request you to please subscribe my channel so that you are notified whenever I post up such a video, because these question answers are important. Okay, so therefore, so that you can get these questions and answers directly, please subscribe the channel and try to get the notification of this video. Okay, so in my next video again I will bring up some more interesting question like this so that your concepts are clear. So thank you.